Hello there! Let's learn how to add and subtract radicals. Multiplying and dividing is easy, but adding and subtracting is just a little bit of a hustle. Let's go. First, and very important rule, you can only add and subtract radicals that have the same degree and the same number within the radical. And I will show you what I mean. In this example, I have 4 square root of 2 minus 7 square root of 2. And what I mean, the degree is the same, that it is a square root. Not here, I do not have a cube root, and here is a square root. They must have the same degree of a radical, and the number within the radical is the same, square root of 2. Square root of 2. I'm only going to work with the coefficients. So I used to have 4 square root of 2s and I took away 7 square root of 2s. So I'm only working with coefficients, so it's going to be 4 minus 7 and leave the square root by itself. 4 minus 7 is negative 3. And I'm just moving my square root of 2. And that is my final answer, negative 3 square root of 2. It's not that you're subtracting square root from the square root. Square root of 2 minus square root of 2, that this will be just 1 or, I don't know, 0. And here you will be just left with negative 3. No. You are moving your square root, your radical, anywhere. Let's do another example. Let's look at the conditions. Are our radicals to the same power? Yes. Square root. Is the number within the radical the same? Yes, it is 2. So now I'm only working with coefficients. 9 minus 3 is 6, and I'm moving square root of 2. And my final answer is 6 square root of 2. You're starting to get the hang of it? I hope so. Let's do the next one. I have 3 square root of 7 minus square root of 7 plus square root of 3. Are the degrees the same? Yes. Is the base, the number within the radical, the same? 7? Yes. 3? No. Therefore, we're not working with 3. We're only working with the radicals that have 7 under it. So 3 minus 1, that is 2 square root of 7. And since we cannot do anything with square root of 3, I'm just writing plus square root of 3. Look, this is not going to be 2 square root of 10. You can use a calculator and check it. This is completely different. This rule does not apply. This rule does not exist. Okay, you cannot just combine the radicals. You can only combine if they're the same. And only then you can combine the coefficients, not the numbers that are within the radical, okay? Let's keep going. What are our like terms here? 2 square root of 3 and minus square root of 3. So I'm working with coefficients. 2 minus 1 is just 1. So I'm just left with 1 square root of 3 plus 2 square root of 5 because I am not doing anything with this square root of 5. I cannot combine square root of 3 with the square root of 5 because there is no rule. This rule does not exist. Okay, let's keep going. Here I have 3 cube root of 5 plus cube root of 40. I cannot just simply add it because the number within the radical is not the same. But what I can do, I can factor my 40 into 5 times 8. And look what I can do now. I can take a cube root of 8. What is a cube root of 8? That is 2. Now look at the magic of math. Because you have the same number under the radical and the same degree of the radical, you can combine it. So 3 plus 2, that is 5 cube root of 5. Just like that. Again, I do not want you to come up with your own rules of radicals. It is so easy to mess it up. I always just plug in the numbers. For example, let's do square root of 1 plus square root of 4. Square root of 1 is 1, square root of 4 is 2. That is 3. Okay, if you were to combine it, that would be square root of 5. Is square root of 5 the same as number 3? No. Square root of 9 is the same as 3. Therefore, you see, this rule does not apply. If you forget this rule, just plug in the numbers. Try to verify this for yourself. Anytime I think of a rule in math, if I'm not sure about it, I just plug in the numbers and see if it works. Here I have square root of 32 plus square root of 50. What am I going to do? Well, I cannot add it because the numbers under the radicals are not the same. Therefore, I'm going to think about how I can factor it. 32, I can factor factor it into 2 and 16, and 50 I can factor into 2 and 25. And in radicals, when we multiply them, we can again separate. We can take square root of 2 times square root of 25. What is square root of 25? That is 5. What is the square root of 16? That is 4. So 32 is actually 4 square root of 2. And 50 is actually 5 square root of 2. What is 4 square root of 2 plus 5 square root of 2? We're adding the coefficients, 9 square root of 2. I hope that you're starting to get the hang of it. If you see that the numbers under the radicals are not the same, try to factor them and make them the same. Let's do another example. Here I have 2 cube root of 2 plus cube root of 54. Let's try to factor 54 into 2 times some number. 54 divided by 2, 27. Let's say cube root of 27. That is 3. So I'm transforming cube root of 54 into 27. No, I'm transforming cube root of 54 into 3 cube root of 2. And look, this is a lot easier to add. So I have 2 cube root of 2 plus 3 cube root of 2. 2 plus 3 is 5, and I'm leaving cube root of 3. And just like that, that is my final answer. What do you think? If you see that the numbers under the radical are not the same, try to make them the same. Try to factor it. If factoring doesn't help, like here, you have square root of 7 and square root of 3. You cannot factor them. It just lives like that. If it just lives like that, then that will be your final answer. You cannot really do anything. But here, if you can factor, try it, okay? Anyways, that is it for this lecture. I hope this made sense, and I hope you do not make up your own rules about adding and subtracting radicals. And yeah, like, subscribe, comment, put notifications on, and I'll see you in the next video. Bye bye.